So hello everyone, this is lecture 37 for the quantum mechanics. So in the last lecture we have completed the harmonic oscillator, but still the questions are remaining. So we'll see them, but first we have to complete this one more topic, that is Compton effect. Then we'll see the questions based on the harmonic oscillator. So let's start the Compton effect. So what is the Compton effect? So we already know that light has a dual nature, and we know that there are many experiments which prove that light has a wave nature, that is interference, diffraction, polarization. But there was only one experiment, that was photoelectric effect, which proved that it has a particle nature. So there was one more experiment, that is Compton effect, in 1923, did by the Compton. So that proved that light has the particle nature also. So today we'll see that thing, that is Compton effect. So what was the Compton effect? So he did that by scattering X-rays radiation from free electrons. He found that the wavelength of the scattered radiation is larger than the wavelength of the incident radiation. So what this says, what he did, he emitted a X-ray and on the free electrons, these are free electrons, and he observed the scattered radiation. Then he found that the wavelength of the scattered radiation is greater than the incident radiation. So normally this doesn't happen according to the classical physics. This doesn't happen means the frequency of this incident radiation should be exactly equal to the scattered radiation. But when he observed this wavelength was greater as compared to this, means frequency was decreased. So means energy of the this scattered photons is decreased. So that's how this effect is called the Compton effect. So first they try to see that by the classical nature. So means classically what happened? Well, let me tell you what classically happens. In classical physics we assume that this is a wave which consider the electric and the magnetic field. So it will oscillate the free electron. So when it incidents on the atom, then it will oscillate the electron inside this, and that oscillation is has a frequency same as the incident radiation, and that's why this oscillation of electron will emit the photon of the same frequency which is incident. That's how things happen in the classical physics, but we are observing that it is not happening this way. So this can be explained only by the assuming that the X-ray photons behave like the particle. So now we will assume that as particle, and we will see that if that actually explains this, the reduction of wavelength, frequency and increase of wavelength, if that explains or not. So classically it should be same, but it is not same. That's why classically it can't be explained. So the wave nature can't explain this Compton effect. So let's study this also. Since the energy of the X-ray radiation is too high to be absorbed by a free electron, the incident X-ray would then provide an oscillating E field which sets the electron into the oscillatory motion, hence making it radiate light with the same frequency. That's what I told you. And also classically the incident means the scattered radiation intensity will be proportional to the incident intensity of the radiation. So these are the classical laws which this doesn't satisfy this experiment. So what actually we observe in the experiment? We observe that there is a difference in the scattered wavelength and the incident wavelength, that is delta lambda, and we call that Compton shift. Now, del lambda depends not on the intensity of the incident radiation but only on the scattering angle theta. We also observe that this change in the wavelength is not depending on the anything of intensity or frequency, means it will be depending on the only angle theta, this deflection angle theta. Means this is an electron and this is a recoiled electron after the collision, and this wavelength change is Compton change is only depending on this theta angle. So we observe that. So what we conclude? Wave nature of radiation unable to explain the outcome of the Compton effect. If we consider particle nature of the radiation, then it can be explained. So now let's consider the particle nature and find the expressions for the change in the wavelength, that what it can be. So let's consider photon as particle, and there is this photon electron collision, and now this collision will be elastic. What is the meaning of elastic collision? That momentum and the kinetic energy will be constant, and if it was inelastic, then means it is that kinetic energy is not constant, momentum is constant. But here it is a elastic collision. So initially the initial momentum equal to final momentum. So initial momentum is for the radiation photon, and for the electron momentum is 0. So incident photon momentum is p. So p plus 0 is equal to, after collision, this is the pe, and this has the momentum as p dash, so it will be pe plus p dash. Now p, the recoiled electron for momentum will be p minus p dash. Now just take the square of this. It will be p square plus p dash square minus 2 p dash. Now p and p dash are the two vector momentum, so there is angle theta between them, p dash and p. So that will be this theta angle, so it will give you cos theta. As you can see here, this p will go like this, and p dash is this. So p dash p will give you p cos theta. So it will be 2 p dash cos theta. Now you know from the de Broglie equation that is lambda equal to h upon p. From here you can find the expression for p, that is h nu by c. So we just substitute here. So we'll find this expression. So p will be h nu by c and p dash will be h nu dash by c. So just substitute the values, you will get this expression. So p square is nothing but this. So this is our first equation which we find from the conservation of momentum. Now let's find something from the conservation of kinetic energy. So energy will be, initially this is the photons energy and this is the rest mass energy of electron. Now this is the actual total energy of electron plus this is the photons energy after scattering. So this is h nu and this is rest mass me c square for the electron and h nu dash for the scattered photon. Now this is the total energy after the collision of electron. So now total energy will be pe c square plus m naught c square whole square e square. I mean this is the rest mass energy plus now it has some extra energy because of the movement. So this is how you explain the total energy. So we write it as E. So it is this expression is here. Now we just substitute the value of means PE square from here. This complete value will be substituted here. This E square will cancel out and H square will be taken common. So here also one H square will came here. So it is a simple math now you need to do. You just need to substitute this value here. And now it will be like this. So take the H common. It will go this side. So this one H will cancel out. This will go in the denominator of this. So now you just need to solve and you need to find the expression for mu naught, means mu naught minus mu dash minus mu. So now this will be this. So it will be a plus b plus c whole square. So just open that square, a square b square c square plus 2ab plus 2bc plus 2ca. Then some terms will cancel out and the remaining one will be adjusted or rearranged in this way. This is a simple math you can do. From here we will find the value of mu minus mu dash. So it will be just this will be taken this side. So it will be this kind of thing. Now this will give you this expression. Now it will be like this way, and this lambda dash means now you can change the mu dash. You know the relation c equal to nu lambda. So nu will be c by lambda. So just substitute here c by lambda. So it will be c lambda dash by c and it will be lambda by c. From here you will find this. Now take this c this side. This one c will cancel out and you will find a delta lambda, that will be h by mec 1 minus cos theta. So this is the Compton shift, means the difference between the wavelength scattered and the initial one. And now you can write this thing constant. This will be lambda c. We call it as Compton wavelength. This is depending on which the particle is colliding and on which the photon is colliding with. So that is that case. So here we have electron, that's why it is me. So this is the expression, and see here this Compton shift is depending on the theta only. So now we can see that when will be the maximum shift and the minimum shift. So for the maximum shift it must be very small value. So cos theta can have minimum value as -1 only. So it will be -1 at theta equal to pi. So that will be 2. So maximum shift will be 2 lambda c, and minimum will be when this will be 1 only, then it will be minimum, that is 0. So for theta equal to 0 it will be the minimum shift in the Compton shift, and maximum will be at theta equal to pi. So that is the thing you can know. Now also you can see that this Compton shift is depending on the mass of the particle with which the photon is colliding. So for the electron we have some kind of means observable Compton effect, but if it is become mass of proton, that means mass of proton is nothing but 1836 times mass of electron. So that will give very less effect on the wavelength. So that's why if the particle size is increasing, then we can't observe the Compton effect. So you just need to remember this value for the electron, because this will be used in the numericals. 2.42 multiplied 10 to the minus 12 meter. So normally when it is not given that with which it is colliding, you will observe that it will be electron. Now we have observed for theta equal to 0, shift will be minimum, and for theta equal to pi, the shift will be maximum. Now we will do some questions. So first you will try them. In the next lecture I will explain. Does delta lambda, only after explaining I will start the new topic. So does delta lambda depends on the wavelength of the incident radiation? So you need to find that. Can we observe Compton effect shift with visible light? If incident visible light, then can we observe the Compton effect? Does delta lambda on the means it will shift depending on the wavelength of the incident radiation or not? Now there will be some kind of plots also. So when theta equal to 0, we will have 0 Compton effect. So that's you will get a lambda curve like this. But if you have some theta 90 or some other theta, then you will observe this Compton effect, means change in the lambda. So it will be like this. You will get two peaks. So this is the Compton shift, and for the theta equal to pi, you will have the maximum shift like this. This kind of curve you will get. So you must remember these curves. Question can be asked directly. So this thing shows the shift in the wavelength. Now this shift can be observed only with the free electrons, not with the bound electrons. So what is the reason behind that? Means if electron is bounded with the atom, then this electron can't vibrate with the, means this whole atom will vibrate with the photon, means it will the photon will collide with complete atom, not the single electron. So this has a very large mass, and we already observed then when there was this proton, then it will have very less Compton effect because of the high mass. But see, now we have a complete atom that will collide with the photon. So now this Compton effect will be very small because there will be large number of protons inside. So that will give you a large mass. So a lambda c will be very small. That's why we want to observe any Compton effect in the bound electrons. So you must remember this thing. It can be asked in the interview. So normally three kind of procedures happens. First, it is that when photon apply on the metal, then there will be photoelectric effect, means the photon will be completely absorbed by the electron. Then electron will emit. So this is the one case, that is a total different thing, photoelectric effect. Then what we study is Compton effect, where this means collision with the free electron, and you will observe the change in the wavelength of the photon, and you will observe the recoiled electron. So this is the second case. This is Compton effect. Third is this atom type, means here this will collide with this atom, and there will be very less movement in the atom, and so there will be no shift, and you will get the same frequency. So that's how things happen here. So these are the three kind of things happen when the photon applied on or the collided with the metal. Now there are some questions you try to solve. In the next lecture I will give the solution. Well, there will be very simple question asked from this Compton effect, directly can be solved. So X-ray lambda is given, are scattered from a target. Find wavelength of the X-ray scattered at the theta equal 45. Find the maximum lambda present in the scattered X-ray. Find the maximum kinetic energy of the recoil electron. So it will be a difference in the energy in the incident and the scattered photon. So here lambda c is not given, so they are scattered from the electron obviously. So you must remember that is electron, it is not given. Next question is photon of energy 0.7 mega electron volt are scattered from electron. If the energy of the scattered photon is 0.5 mega electron volt, find the Compton shift, theta, and this recoil angle. So recoil angle is this one. This is theta, this is recoil angle, and find the kinetic energy. Next question is theta is given, lambda dash is given 0.9 picometer. Find lambda e of the incident photon. Then find the energy of electron and use the recoil angle. Using energy and momentum conservation so that a free electron can't absorb all the energy of the photon. So try to solve them or to prove this. A photon whose energy equal to rest mass energy of the electron undergoes a Compton collision with an electron. If the electron moves off at an angle of 40 degree with the original photon direction, what is the energy of the scattered photon? Two more questions. Prove that kinetic energy maximum is this 2h square mu square mc square 1 plus 2h nu by mc square. Find the energy of an X-ray photon which can impart a maximum energy of 50 kilo electron volt to an electron. So try to solve these questions. In the next lecture we will first solve them, or I will just give you the hint that how to solve them for some questions, and then we will study the harmonic oscillator based, means all type questions based on the harmonic oscillator. So that's all for today. Thank you everyone.